Okay, so scientific notation is used science mostly in measuring really big numbers, distances like distance from Earth to Pluto. They would measure in or use scientific notation to show that instead of writing lots and lots of zeros on the end of a number. They also use it for measuring really small things that are less than one. Decimal, really small decimal numbers that have many zeros to get to that value. But the way that this works, and we'll look at them, but this is what you need to have written down if you're keeping your notes like you should be. It's a three-step process to write a number or change a number into scientific notation. 1, you place the decimal after the first non-zero number. And I'll go over here in just a minute and explain non-zero and that type of stuff, but I just want to get it written down so that you can focus then on the process. 2, determine, that should be how many places the decimal was moved. I'm not sure how I missed that the first couple of lessons, times I taught this year. And 3, write the exponent on 10 as the number of places you move the decimal. You were introduced to this, at least introduced to it last year, if not involved with it a bunch, probably. And so hopefully, if you had troubles with it last year, it'll be easier just because it's the second time around of seeing it, gotten away from it. Hopefully we can get back into it.
Hang on.
Hang on, please.
Yeah.
Raise your hand.
Please. Reminds me of my Spanish teacher in high school.
We both said it at the same time.
She told us Kente quite a bit. Kente. Be quiet. You know what that is?
Oh,
What is it?
I see.
Is that what, maybe that's what she was saying. All right. Here is a number in scientific notation. This is the form for it. We're not trying to solve it, we're not trying to simplify it, I just wanted to show you the form. As you can see, in your first instructions on the steps there on changing numbers, we have the decimal after our first number. Okay, we say non-zero because we don't want a zero in that spot. So it's after our first number is our decimal, and then it's times 10 to the 5th power. Okay, the exponent on 10 would have been determined or derived from more of the problem, and so let's see how that works. So here's our number, 7,024,000. We need to write that in scientific notation. So our first number, or first non-zero number, is 7. So I'm going to write 7, and then any of the numbers that follow it that aren't 0. Now I do have to keep this 0 because it's in front of the 20, of the 2 and the 4. These extra zeros at the end, I don't because it's part of the decimal value, so I don't have to have those on the end. Then we're going to go times 10. Now, Mariah, where's the decimal at on 7,024,000 to begin with? Up here. We don't see one, so where's it at?
The end.
It's at the end. So if it's at the end, and then I wrote it between 7 and 0, how far did we move that? Thank you for raising your hand, Dawson.
Oh, I got the answer.
I'm not looking for an answer. I'm looking for how many places did we move this?
6.
6. Okay. So if we move our decimal 6 places, then the exponent we're putting on our 10 is going to be 6. That exponent represents the number of places we move the decimal. 7.024 times 10 to the 6. This is scientific notation, and we want to leave it in that form. We're just changing it. It still has the same value of 7,024,000. It just looks a little different, so you can get used to writing things in scientific notation. Okay, writing this one in scientific notation, our first step is to put the decimal after our first number. Kelsey, what's our first number?
3? No, 4.
In our number entirely, the 4. So we're going to put the decimal after the 4, and then I'm going to write everything else after that until I get to my zeros, which is at that point. Then it's always times 10. Kenny, how far did I move the decimal from where it was at to where I put it?
2 places.
2 places, so that's the value of the exponent on there.
So you don't have to find the answer.
You know, the answer, if you were to go backwards, would be that. They're the same thing. Okay. All right, decimals, writing them, same process. We're going to put the decimal after the first non-zero number. Xavier, what's the first non-zero number? 6. So we have 6.52 times 10. Yes?
Don't you have to put a negative exponent?
That is correct. So let's first, how many decimal places did you move it?
4.
1, 2, because it's 6.52. And then that is, we moved it 2 places.
So 10 to the second power.
And since we started off as a value less than 1, is that 0.0052 is a value less than 1, it's going to be a negative exponent. Ashley?
I was wondering if you're recording it, but I saw the video.
Yes. Kelsey got me started on that. So here's the difference. When you start with a number that you're trying to write in scientific notation, Azarian, that is greater than 1, then your exponent is a positive exponent. So just 2, 4, whatever it is. When you start with a value less than 1, decimal value, then your answer is, or your exponent on your 10 is going to be a negative exponent. I used to try to teach you move it this way in this situation. You don't need to do that. You just need to know if it's greater than 1, it's a positive exponent. If it's less than 1, then it's a negative exponent. All right, so let's change both of these now from scientific notation into standard form. Alyssa, looking at this, has a negative exponent. So what does that tell us about the type of number we began with?
Like, I don't know how, like, the decimal is before the.
Okay, it's going to be a decimal value, isn't it? We're going to move it to the left and give us a value that's less than 1. So that's we're going to move our decimal left, and then we look at the exponent 4 places. So we have to count the 4 as one of those spots. So there's 1, 2, 3, 4. So I would need 3 zeros. So my answer for that, or the standard form for that, would be 0.00046. Number 2 here, Megan. Since it's a positive, what's our number going to look like when we get done changing it? Is it going to be a decimal number, or is it going to be a number bigger than 1? Bigger than 1, since it's positive. So that means I would move my decimal to the right to make it a number bigger than 1. So I'm going to move it 4 places. 1, 2, 3, 4. That's 4, 6, and then 1, 2, 3. 3 zeros. 46,000.
Petroleum jelly is flammable, right?
I have no idea.
Sorry,
I'll distract it.
yeah, I was
Okay.
thinking about that. Like,
Writing this one, looking at the exponent, Brianna, is it going to give us a decimal value when we write the standard form, or a number bigger than 1? Bigger than 1, because we're moving it to the right. 1, 2, 3, 4, 5. That's 9, 2, 7, 7, 0, 0. Following that? Pretty simple. Do you understand we're going to get into more complicated things.
Mr. Clevenger,
Yes, ma'am.
could you have Caleb come to the office?
Yes, please.
Wait, no, we'll do 8 through 19. It's good. It's all good.
Five. You have games tonight. They are here.
And I'm grounded. So, I need to turn them off.
So, for now anyway.
Yes.
Alright. I don't want to do this.
I should
5
be
through
grounded
10.
all weekend. So, you might want to give me some of that time back too.
Like,
5 through
I'd
10.
say 21.
That's decent.
Yeah, 22.
And the odd numbers of that.
Why, so you could copy the answer?
Yeah. But I already have it done actually. It's like, doesn't matter. Trying to help you all out.
Oh man. We need to do those, so 13.
Oh.
15, 14.
No, not
15 through 6. No, 6, 16.
See, look what you did.
Yes. Wait. Yes. I did 20.
Stop it right there. No. Okay, yeah.
Is that it?
And 22.
Okay.
That work?
No more comments about what to assign and not to assign. Thank you. 22 through, we need to do that, we need to do that. 27.
Yeah.
I don't put it right.
Do they? You may.
Can we work with a partner?
No.
Yeah,
You may sit on the floor. Yes.
Chris,
You want to do one first? Okay, so that's the total amount of money you paid. It's kind of a grouping problem, where the 64,000 is, excuse me, is total, and then you have the groups are the stocks, and each, the value of a stock, value is what, 40?
Yeah.
$40 times, and then our missing value. We don't know how many stocks we have. We know we want to invest that much, so how would we find that missing? Divide.
Do you have a paper clip or something to where I can get this here so
I have even better than that.
Oh, what is that, bro? I like it. I'll buy you one.
That's not enough.
are you trying to bribe me? Yes.
The other day I read these
What was that for?
Hey, don't be slamming doors like that, Broken.
You got another Friday school?
Yes. Very soon.
Everybody
Everybody just takes my words.
Right. I wonder if it's just like sitting off and like some.
The assembly thing. Oh no, it's cool, I've been too loud.
Are you serious?
Yeah, I got a meeting for it. Thursday, I'm sorry, it's Thursday this time.
We need to roll the jerseys
Oh, you got it today?
No, it's next Thursday.
That's retarded. You don't know how
All right.
slow it is.
Go ahead. Caleb, I want you to stop talking about it, and I want to chat with you after class. That's what I want. Do you want it all the way